Now, from the observations that were made, we get the times at which the depth of the water in the container was each of these, measured relative to the point where the flow stopped. Okay? Now, we assume that the functional relationship between y and t is of the form y equals at squared plus bt plus c. This is what physics predicts this. For an ideal fluid. Now, we don't know to what extent maybe water is ideal, but there we have it. So the analysis that everybody's been asked to do is to first write down the equation corresponding to each row, to each observation, okay? So for the first, y is 138. Now, we're just going to use the numbers, but we know that this is in millimeters, and t is in counts, and the counts varied from one group to another because they were done by pacing. Y is 138, t is 8. So we plug in 138 for y, and that's going to be equal to a t squared, right? That's a times 8 squared plus bt, which is b times 8, plus c. And there's our first equation. And our second equation is going to be what? Y is 83 now. It's going to be 83 times a times 41 squared plus b times 41 plus c. Okay, well, then we're going to get 3 more equations. Now, I would then rearrange the equations. I'll rearrange the first 2 into the form, well, I'm going to go ahead and do the arithmetic. 64a plus 8b plus c equals 138. And it's obvious that this is the same equation this is. I've just done the arithmetic here. And let's see, 41 squared is, it's 1600 and 160, 1761, I think. So that would be 1761a plus 41b plus c equals 83. Now, I've just reversed the sides of the equation, so these are in the kind of form traditional for a set of simultaneous equations. Okay, well, I'm going to write the rest of the equations up here. I'm not going to write the rest of the equations down here because I'm going to show you what we would do with these 2 equations. But I'll write the rest of these equations up here just to make sure that you see what they would be. And naturally, your numbers are going to be different than these. And I don't think that the numbers I've got here are likely to be all that consistent with the assumption of a quadratic function. But we'll see.